Hello guys, welcome to today's session. We are going to solve a simple circuit by using the Kirchhoff current law. Okay, in this case we have a simple circuit with two sources, two current sources and three resistors. Okay, so we are asked to calculate the voltage across 4 ohm resistor, the current across 2 ohm resistor, and the current through 3 ohm resistor. Okay, so as we see, we only have current sources, we only have resistors, so we have a simple circuit. Kirchhoff current law states that the currents in a node of a circuit, the addition of the currents in a node of a circuit equals zero. Okay, I mean that uh, the addition of the incoming currents equals the addition of the outgoing currents, to say it in a more easy way. Okay, so we have first of all we have to identify or to set a reference node in case we don't have it. We can see in this circuit that we have a ground node on the lower left of the circuit. Okay, so this is going to be my reference node. In case I don't have it, I will have to set a reference node wherever I want. Okay, in this case it is set there. I'm going to keep it there, and as I said before, as this is my reference node, this is my 0 volt node. Okay, so all the voltages in my circuit are going to be referenced with respect to this node, to ground. Okay, now after setting my reference node, after identifying my reference node, I have to identify the rest nodes of the circuit. Okay, in this case, as I can see uh, on the draw, uh, there are two more nodes, A and B. Okay, from which I'm going to get equations from. Okay, this is node A, as I'm pointing right now, and node B, because the lower right node of the circuit is the same as my reference node, because it is connected by means of a wire. Okay, so I only have two nodes to solve. Okay, so once I identified the nodes, I'm going to use the equations I stated previously to try to get the equations of each node. Okay. For example, let's try to get the equations for node A. Okay. In the case of Kirchhoff's current law, I'm going to work with currents in order to find the voltages in the nodes. Okay, but uh, as I'm going to work with currents, the first thing I have to do is to draw currents going into the node or coming out from the node, wherever direction I want. Okay, in this case, look that I drew I1 from left to right. Okay, going into node A. Then I drew current 2, I2, which is coming out from node A, and I drew current 3, I3, coming out from node A. As I said before, you can draw these currents in any direction you want. Depending on the direction, the calculations are going to be different regarding the sign of the voltages. Okay, so in node A, according to Kirchhoff current law, uh, as the incoming current is I1 and I2 and I3 are outgoing currents, so I have that I1 equals I2 plus I3. As I see in the circuit, I1 is given by the current of the current source, the 6 ampere current source on the left. So I1 equals 6, okay? So 6 equals I2. I2, I'm going to express it by using Ohm's law, okay? I know that the current across a resistor equals the voltage difference across across it divided by its resistance, okay? So to find I2, I uh, the way I drew I2 causes a voltage drop with the polarity I can see across resistor 2 with the positive terminal um, on the upper side of the resistor and the negative polarity on the lower part of the resistor. So according to this, I2 equals VA, because the positive terminal of resistor 2 equals the voltage at node VA, and the negative uh, voltage of the negative terminal of the resistor uh, equals ground node, so its voltage is 0 volt. So the current across I2 equals VA minus 0 divided by the resistance of the 2 ohm resistor, which is 2. In the same way, I calculate I3, okay, which is, according to Ohm's law again, is the voltage in node A, which is the positive terminal of the resistor, minus the voltage in terminal in node B, okay, divided by the resistance of the 4 ohm resistor. In this case, I could get VA minus VB divided by 4. So by solving this equation, I can get equation 1, which is 3 times VA minus VB equals 24. The same way, I'm going to get the equations from node B. Okay, the same as I did before, I draw currents in any direction I want. In this case, I have an incoming current that I drew before when I was working with node A. In this case, it is I3. This is an incoming current for node B. And I drew I4 going down on purpose, okay? And I drew I5 going down as well. So according to this and according to Kirchhoff current law, the incoming currents I3, the addition of the incoming currents I3 equals I4 plus I5. I am surrounding I4 there because, as you can see, the current in that branch is given by the current source, the 1 ampere current source. But I drew I4 going down, and the current source is going up. So in this case, as you can see in the equation, I have to write minus 1 for the current through that branch, okay? Because the way I drew I4 is opposite to the actual direction of the current. Okay, so to write I3 on the left of the equation, I use the same procedure as before. It would be VA minus VB divided by the resistance, which is 4 ohm. Okay, this equals minus 1, as I explained before. The reason of the minus sign of this value, plus I5. Okay, in this case, according to the way I drew I5, this current produces a voltage drop with the polarity shown on the circuit. Okay, so by using Ohm's law, I can get that I5 equals VB, which is the voltage at the positive node of the resistor, minus V0, which is the voltage of the negative terminal of the 3 ohm resistor, divided by 3. Okay, so by solving this second equation, I can get the resulting equation you can see, you are going to see right now. So as I said before, you can draw the currents um, in the nodes in any direction you want. Okay, depending on the direction you draw it, you're going to get one result or another. The only thing that is going to change is the polarity of the sign of the results. Sorry. Okay, so we have equation 1 and equation 2. Uh, so we solve this equations system, and as I said before, what I'm going to get from this circuit when I solve it by means of using Kirchhoff current law is the voltages in the different nodes of the circuit. Okay, in this case, as I said, we have 3 nodes, one known node, which is the reference node, whose voltage is 0 because it is my ground node, my reference node, and from these two equations, I'm going to get the voltages in the nodes, and from these voltages in these nodes, I'm going to get the different currents um, I want. Okay, so uh, as I explained before, look at the lower right node, which is 0 volt as well, because it is connected to my reference node. Okay, so by solving this, I get that VB equals um, 6 volt. Okay, this case is 6 volt. I forgot to write the units. Okay, and by substituting this value in the equation, I'm going to get the value of the voltage in node A. This VB is the voltage in node B. Okay, so I substitute it here, and I'm going to get the voltage in node A, which we are going to get right now. Okay, so the voltage at node BA equals 10 volt. Okay, so VB is 6 volts with respect to ground, and VA equals 10 volt with respect to the same ground, my reference node. Okay, so I2, which is the current through 2 ohm resistor, which I was asked to calculate, equals, as I wrote before, you can see it on the upper left when I solved node A equation. I can get that I2 equals VA, which is 10 minus 0 divided by 2, and I2 equals 5 ampere. Okay, so I got I2, and if I take a look to the circuit, I can see that I2 is the current through 2 ohm uh, resistor. So one unknown is solved, okay? And now I have to get current through uh, 3 ohm resistor. If I take a look to the circuit, the current through the 3 ohm resistor equals I5, which I got its equation when I was solving equations for node B, as I am surrounding on the upper right. Okay, so I5 equals 6, which is the voltage at node B, minus 0 divided by 3. Okay, so the current I get for uh, this, or the current I get, the current that is going through resistor 3 of 3 ohm, the 3 ohm resistor equals 2 ampere. Okay, and now I have to calculate the voltage across 4 ohm resistor. As you can see in the circuit, it is the voltage at the positive terminal minus the voltage at the negative terminal. Okay, so I already got VA, I already got VB, and I could directly get this voltage difference, but I'm going to do it by Ohm's law. Okay, by Ohm's law, the current I3 that is going through the resistor causes a voltage polarity, the polarity you are looking at the circuit, so it is equal to I3 times 4 ohm. Okay, so I3, which I didn't got before, I have to get it now. I3 equals VA, which is the positive terminal of the resistor, minus VB divided by 4 times 4, and this equals what I said before. I said before that I could get this voltage difference directly by subtracting VA minus VB. So the voltage across the 4 ohm resistor equals uh, 4 volt, okay, with the polarity shown in the circuit, which is surrounded by orange circles. So now I'm going to simulate this circuit by using LTSpice. Okay, first of all, I'm going to get the current through 2 ohm resistor, as you are uh, seeing here. Okay, so it equals 5 volt as I calculated. Okay, and you can see surrounded in the box. Okay, later I will find the voltage across 4 ohm resistor, but now I'm going to get the current through the 3 ohm resistor. Okay, and I see that it is 2 ampere, and when calculating the voltage difference across the resistor, 4 ohm resistor, I'm going to get that it is 4 volt. Okay, I hope you liked this video. If you like it, thumbs up, and please subscribe for later videos.